Sine of angle A over side A. Sine of angle B over side B. Yes, it is a proportion. The law of sines is a proportion. And when we saw the triangle using it, here's the law of sines. Remember, capital letters denote angles, small letter denotes sides.
Hey, I got one right. Let's go.
So here's a triangle we're going to solve. Let's say we know angle A is 58 degrees and angle B is 72 degrees and this side is 12. And we are going to solve this triangle. Now that means we are going to find everything we don't know. So we need side B, we need side A, and we need angle C. Now, of those pieces, one of them is a no-brainer. You do not need the law of sines to find one of those pieces. Angle C. We know angle C is going to be how big?
130, 50.
50 degrees. And we know it's 50 degrees because why?
72 plus 58 is 130, 180.
The angles of a triangle have to add up to 180, right? So if we know two of them, we can automatically find the third one. Okay, now, you heard me say a minute ago that we can solve every triangle in the whole wide world using SOHCAHTOA law of sines or law of cosine. SOHCAHTOA is not going to work here, not a right triangle. How do I know when I'm going to use the law of sines, and how do I know when I'm going to use the law of cosines? Here's the key. When you have a set, and when I say a set, I mean when you have an angle and its opposite side. So I have angle C and side C. When you have that information, you're going to use the law of sines. Those of you that did the work last night, memorized your laws, which law is easier to memorize?
Sine.
Law of sines, right? It's the easiest one to use. So we want to use the law of sines whenever we possibly can. We can't always. We use the law of sines when we have this configuration. Okay, so then that tells me I'm going to start out by saying sine 50 over 12. Sine 50 over 12. And then you decide. You can either say sine 58 over A, or you can say sine 72 over B. You're going to have to do both, so it really doesn't make any difference. I'll just start with A. I'll go alphabetically. So this is sine 58 over A. Everybody clear on the setup? So then we cross multiply and divide. So A is going to equal 12 sine 58 over sine 50. So we take out, all of this is totally calculator dependent. We're going to use a calculator every single day on every single problem. So if we're not in the habit of bringing our calculators, we need to do make sure you're set in degrees. And what did you get for side A? Nearest hundredth. Side A? 13.28. Now, there's always somebody in the crowd that wants to do the Pythagorean Theorem at this point. Of course, that's not possible. Even though I have two sides, I'm not going to do the Pythagorean Theorem because why? Not a right triangle. I'm going to use my law of sines again, only this time the setup will be sine 50 over 12 equals what? Sine 72 over B, perfect. So we cross multiply again. Oops. And then divide. So B equals 12 sine 72 over sine 50. And again, I go to my calculator because I'm going to be using it on every single part of every single problem. And what did you get for side B? 14. Yeah, there it is. Now, does anybody have a question about that? The law of sines is incredibly simple with one exception. So now I'm going to do the exception. I'm going to do the tricky part of the law of sines. But so before I erase this, everybody's clear on all the arithmetic that we did here. Pretty easy. We know when we have this set of information, when we have an angle and its side, we're going to use the law of sines. Okay. So before I go any far, before I erase this, I want you to pay attention to what I gave you. When I started this problem, didn't I give you this, this, and this? Isn't that what I gave you? This is important. From geometry, what I gave you was angle, side, angle. Remember that stuff, proving triangles congruent? Okay, and everything worked out perfectly. It was wonderful. Angle, side, angle. Okay, take a look at this one now. Now, is this a law of sines problem? Remember I told you, what do you have to have if you're going to use law of sines? You've got to have a set, right? An angle and its side. Do I have that? Yes. Okay, so I'm going to set up my law of sines. There's something different about this, though. Whenever this happens to you, whenever you set up your law of sines, and would you agree it would look like that when I set it up? Whenever you set up your law of sines, and you're solving for an angle, this puts you on high alert. Your little antennae are up. This situation is caused by the configuration of information you have. Remember a minute ago I had angle, side, angle? What do I have here? Okay, and remember in geometry, you could do side, 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 you could do side, angle, side, but Harvey's all embarrassed because this is a bad word. We couldn't use this one, right? And the reason we couldn't use it is because it doesn't always define a unique triangle. We are in a situation now, we're going to do this problem. We're going to do it. But we might have no solutions, we might have one, and we might have two. And we just never know. So whenever this situation arises, you must be on the lookout for the potential of a second answer. All right, so here's how it works. I'm going to multiply over here. And now I'm going to type into my calculator 12 sine 58 divided by 11. Okay, now you got a decimal, right? Logan, where's your calculator?
This is my backpack.
Well, why don't we get it out, Logan? And kind of join the crowd. And Redor, you might want to be pressing buttons with us. So we've got 12 sine 58 over 11. We got that typed in and it's a decimal. Now, is that decimal angle C? No. What is that decimal? It's the sine of C. How do I get the angle? Second sine, second answer. And that angle came out to be 67.69 degrees. So I second sine, second answer. My answer button is right down in the bottom row on my negative. So you should have gotten 67.69. Now, as soon as that happens, you're going to step over to the side and you're going to redraw the given information. And then you're going to say, there is potentially a second answer for angle C. One of the answers is right here, and it is good. The second answer will always be the supplement of the first answer. So what do I mean by supplement? 180 minus. So I'm going to take 180 minus my 67, and this would be 112.31. And then I say to myself, is it possible to have a triangle with a 58 and 112? Is that possible? The answer is yes, because 58 and 112 add up to be less than 180. Now, if I would have gotten, let's say I got a different number here, and my supplement worked out to be 132, would that triangle be possible? No. So in that situation, only the original would be acceptable. In our situation, we have two different triangles possible. Angle side-side is referred to as the ambiguous case. Ambiguous because sometimes it defines one triangle, sometimes it defines two, and sometimes it defines none. We're going to do one of each. This is our two triangle example. So let me back up. Let's get to this point again, make sure everybody's on board, and then we'll finish the problem. Okay, step one. Here was the given. I had a pair, so I set up my law signs. As soon as I wrote this, as soon as I said, oh, my variable is an angle, alert. So I worked it out, got 67 as an answer. I immediately said, okay, I'm on alert. This is the ambiguous case. If 67 is an answer, so potentially is its supplement. It will always be the supplement. So if this one works out to be 50, this is 130. If this is 80, this is 100. They're always supplements. Then I stand back and say, is that even possible? And the answer is yes. So now I have two triangles to solve. So I need to finish this one, and then I'll finish that one. So now I know this is 58, this is 67.69. Can I find angle B? Say, why, yes, Mrs. Ford, you can find that by simply subtracting the other two from 180. So it's 54.31. Now, how do I find side B? What am I going to do to find side B? That's the only thing left. Actually, sweetheart, let's use this one because there's no round off there. So we'll use sine 58 over 11. Since that was given data, there's no round off. So sine 58 over 11 equals, what did you say, Katie?
Equals sine B over
54.31 over B. You take the sine of the angle over the side. So I'm going to cross multiply and divide. I've done so many millions of these in my life, I can do that all in one. You maybe can too. And I got 10.53. Anybody match that? So that triangle is done. Remember, our objective was to solve the triangle. But we had two. So now we got to step over. We need to finish this one. So we'll go through all the same work. Only now I have a 58 and a 112. So So this angle is only 9.69. It's a tiny little thing. So now I need this side B. So what will I write? Sine 9.69 over B equals sine 58 over 11. So B will equal 11 sine 9.69 over sine 58. Ooh, I got a tiny little number, 2.18. Does that make sense? Why does that make sense? Tiny little angle. Remember the hinge theorem from geometry. The smaller the angle, the smaller the side. So there you go. All right, you ready for the next one? Here we go. All right, here we go. You're walking down the hallway, you find this triangle, you have to solve it. So you immediately think, okay, am I going to use the law of sines or the law of cosines? You're going to use the law of sines. So you're going to say sine 71 over 6 equals sine p over 11. But the minute you write this down, you say, whoop, whoop, whoop. Right? Little antenna. So sine p. And the reason we're on alert is not because we can't do the problem. We can do the problem. We just don't know how many problems we're going to have to do. So sine p equals 11 sine 71 over 6. All right, let's figure out angle p. So we type 11 sine 71 divided by 6. That number is not the answer, right? That number is the sine of p. So what do we have to do to get p? Second sine, second answer. Okay, time, where's your calculator?
It's broken.
It's broken.
So I have to keep stealing Meg because he's getting mad at me.
What happened? It doesn't work. It doesn't work. What do you think that means? No solutions. This triangle does not exist. Remember, angle side side is called ambiguous. And it's called ambiguous because when you find that data, angle side side, you might have no triangles, you might have one, and you might have two. So we just did an example where we had two. This is an example where we don't have any. And how will we know that we don't have any? Our calculator will tell us. Right? No triangles possible. So we say no solution, and we move on. All right, so here's the next one. Our job is to solve this triangle. Ben Harvey? Our job is to solve this triangle. So here we go. What's our setup? Sine 63 over 10. Okay, and the minute I write that, here we are. We got our situation again. So let's see what happens. here? 9 sine 63 over 10.
So you do 9
And I got a decimal. So I have to second sign that decimal. Oh, I got an answer this time, did you? 53.31. Now, who remembers what I do as soon as I get that answer? What do I do immediately?
Try to see if there's
I
another
draw
triangle.
the second triangle, the potential second triangle. Remember, we do not know that it's going to work. And we label everything that's given exactly the way we started. And then, instead of 53.31, we try the supplement, 126.69.
Yeah. Which doesn't work.
Which doesn't work. Does everybody see what's wrong with that triangle there, that second triangle?
It's already 180.
It's already
past
more
50.
than 180. So this one doesn't work. So how many solutions for this data? 1. And how do we finish it then? We only have one to solve. This is it. How do we solve it? Yep, we can do 180 minus 53.31 and 63. So 63.69 up here. And then what?
Then you solve for little m.
Solve for little m, and how would that look, Stephen?
You can do proportion.
I do more
Sine,
signs.
63 over 10 equals sine 63.69 over n.
Exactly. So little m will be 10 sine 63.69 over sine 63. It's got to be close to 10, isn't it? .06? And that makes sense, doesn't it? Because these two angles are so close, so triangles are almost isosceles. Everybody okay? Now let me hand out a couple of things and we'll practice a little bit.
Whoa. Someone be doing some shit. You know, angle side.
Next to oatmeal.
Tom told me about that.
I'm so glad I forgot. The best part about tweet. I was about to triple tweet.
What I would like you to do right now on handing out some more papers is if you would turn in the packet I just gave you to the back of the second page. Pardon me? Oh, I didn't give you guys any?
I thought we were your favorite students.
Just get through. What the heck?
Wow. I think you did it on purpose.
No, I would never do that. Okay, so are we on the back of the second page? Look at the first problem number 1. It says find the number of triangles possible. So what I would like you to do, that's sort of what we were doing here, only we were actually solving here, doing more than that. All I want you to do now is get to the point where you can tell me there's either no triangles, 1 or 2. Now you're going to have to do some work, remember, we had to do some work.
These are all.
But you're not going to have to find everything for every problem. But I'd like you to work on those 4 right now while I get organized handing out the rest of
Oh, all right.
and take your attendance. So we are missing Maggie.
Oh God.
Right, make sure you write it.
Playing one shot.
Could be zero here.
Asking for change.
The only one. Just one of the zeros. Yeah, that's not A. Everyone has two angles on one side.
That's only the first.
Could be zero? No. First one's side angle.
This is already in your
It's making me do better.
How bad is mine? How bad's mine?
Of course.
Yes.
Oh, by the way, I need to tell you too, I had a parent, bless that parent's heart, ask me last night what accommodations I was making for senioritis. And my answer was none. So just so we're all on the same page.
Just slap that.
Did you hit him?
So funny.
I know, I thought, yeah.
What do you think I said?
We all know.
You guys just should have slapped that pants.
Katie, what?
No, he said he would never.
She did say parent.
Wait, would you?
Katie wouldn't, no. We just got like.
Okay, sexual assault is never the answer.
This is a good conversation. It's making Katie feel uncomfortable, I can tell.
Yeah, see this. Oh, you didn't know.
Yo, I think we're doing okay.
Yeah, I'm almost ready to run over here. I hope you are making progress.
I did that. I don't have plans. I don't have plans.
Oh, why?
Side 36 over 10.
No one might. Yes, you did.
I don't like the news.
I don't have a calculator, so we can't do this.
Numbers and try to crunch on it.
So what numbers are they? Whoa, A, B, C, D there?
I think I'm like, one of my favorite friends is just going to her now. She goes, you're the worst person I know. I don't know why I'm doing this. I'm the one side, but I just keep. Yeah, totally. It's just something to do. Give me.
How many triangles did you get for the first one?
One.
Yes, and I don't know if you noticed this or not, but you knew there would be one because this was not even an alert situation.
Alert.
Did you notice that? That's not an alert situation. You said sine 36 over, wait a minute. I knew that was 10.
There's two
Sine
angles.
36 over 10 equals sine 73 over b.
So if there's two angles in a problem, you don't even need it.
So that's one solution. That's one solution. When do we know we have a potential for either none or two? When we are solving for the sine. Now, did that happen in problem B? A was 36, side A was 10, and side B was 8. Yeah, this is going to give us an issue. Because we're going to say sine B over A, right? So what did you do? Hopefully you typed 8 sine 36 divided by 10. And you got a decimal.
Yeah.
Then you second signed that decimal and got 28 point whatever. Now, I know I have at least one answer. So then I step over to the side and I figure out if I could have a second answer. And if I do have a second answer, what would it be? 151.95? Is that possible?
No.
No. So what was the answer to this question? One triangle. There's one triangle, the original one you found. The second one isn't possible because it would make more than 180. You got it? Did anybody get to the second one? Or the third one, I mean, C?
Yeah.
What happened there?
No solution.
No solutions. I want to talk about that for a quick second. When you typed in on your calculator, sine 36 over 3 equals sine B over 8. So we know this is our work situation. So we have sine B equals 8 sine 36 over 3. Tell me about that decimal. It's bigger than 1. And what do we know about sines and cosines? Think about sines and cosines. What do we know about them? They're never bigger than 1. So as soon as you get a number bigger than 1, you know that's going to be no solutions. That can't be. That triangle doesn't exist. You can't draw a triangle with those sides and that angle.
So, for this one, I got,
Okay? Did anybody get the last one?
and then sine 73 over B. And multiply this, we're going to submultiply, get the 10 under it, and then you divide.
Anybody get this one?
But
Sine 36 over 9 equals sine B over 10.
then it's big.
So sine B equals 10 sine 36 over 9. All right, this is an alert situation. Let's see what happens. Okay, I'm going to get an answer.
Oh, wait, is there?
It's 40.
Oh, that has anything to do with it.
So then I immediately draw the picture again and check the second answer, which will be 180 minus this one, which is 139.22. Can I have a 36 and a 139 in the same triangle? Yeah, it would be a weird shaped triangle, but it's possible. So how many solutions for that last set of data? 2. Tonight's homework, Yang, is in the book. I want to call your attention to problems. Okay, this is on page 484. And I want to call your attention to 13 through 18 anyway. The directions for 13 through 18 are exactly what you just did. They're simply asking you how many triangles are possible. So you need to do as much work as that requires, but as soon as you can figure out, oh, there's only one, or there's two, or there's none, you're done and you move on. You don't have to find all the angles and sides. Okay, you have to find some to get the answer, but you don't have to finish the problem. Clear on that? All right, I want you to go ahead and get started on that right now.
Yeah.
Dude, give me that bullshit.
Stephen, can you flip me off? Or I shouldn't say flip me off. Can you turn me off there?
Should take me out, kid. Let's go, get up.
We just had
Go,
this,
boy.